Welcome to the Advanced Metalworks Enterprise 2020 Design Expo presentation. Our slogan is Diverse, Capable Leaders. We work on R&D projects related to material science and manufacturing for industrial sponsors. Our 2019-2020 project sponsors are ArcelorMittal and Mercury Marine. Meet the teams. This year we had 3 teams, 1 senior design team and 2 underclass teams. This presentation will go over the undergraduate team projects and what we are proud to have accomplished this year. The objective of our project was to assess the microstructure and fracture surface relationship to the ductile and brittle fracture of advanced high-strength steel. We focused on finding what temperature the steel transitioned from ductile to brittle behavior to determine if the steel was suitable for typical service conditions. This is important because if the ductile to brittle transition temperature is too high, then parts on the heavy equipment the steel will be used on can fail catastrophically on cold days. For this project, we were given 16 different Sharpie bar samples made with 2 different cooling rates and tested at temperatures from -10 degrees C to 300 degrees C. These samples were analyzed using microscopes to get a close look at the microstructure and fracture surface. Our results show that the ductile to brittle transition temperature for these steel Sharpie bars was influenced both by the microstructure and the grain size of the sample. In addition, we found that the transition temperature was higher than a typical steel, meaning that the material is brittle in its typical service conditions. Overall, the cooling rate difference between the 2 samples is the main factor that is changing the microstructure and grain size of both of these samples. The second undergraduate project was the Quencher Partition heat treat of 3D printed steel using wire arc welding technology. The team members are Mike, Ross, Ty, and Liam. The goal of this project is to print a high-strength steel via wire arc additive manufacturing, or WAAM for short. 3D additive manufacturing is a method that is growing rapidly and has many advantages compared to other current manufacturing processes. This includes less waste than standard machining processes, the ability to produce very complex parts that could not be produced by any other means, as well as the ability to send part files over large distances instantly that can be printed without the use of expensive dies. Quencher Partition, or QMP for short, is a heat treatment method which is supposed to enhance the ductility of the steel without significantly decreasing the strength. This heat treatment has a variety of applications, as high-strength steels with relatively good ductility can be useful for any part. One industry that comes to mind is automotive, as QMP steels allow automotive industries to use less steel while maintaining passenger safety to improve fuel economy. Putting the 2 processes together can add both these benefits to optimize structural components. During the course of this project, a custom composition core wire was developed and produced. From this wire, samples were printed, including small cubes and small tensile bars. Using these samples, the before and after heat treatment microstructure was found. Before QMP, the microstructure consisted mostly of martensite and ferrite. After QMP, the microstructure consisted of what is to be believed retained austenite, ferrite, and martensite in different fractions that has yet to be confirmed. The tensile bar specimens have not yet been tested for tensile strength, but will be within the coming days. Expected is a similar strength for non-QMP specimens, but higher ductility. Another test that is planned is a statistical test on multiple pieces to optimize the heat treatment. Overall, the project yielded successful material production and low porosity printed samples that composed the composition that was chosen from a multitude of sources and simulations. The QMP process has been refined substantially to provide decent characteristics, but could be improved even further. The sponsor processed a sample and a test called dilatometry to help refine the heat treatment temperatures. Heat treatment times were estimated using thermocalc software. In the future, the biggest factors to watch for in use of this method is material porosity and manganese vaporization. If you have any questions or comments on any project details or want to get in touch with a representative of AME, please contact any of the following members. Thank you for your attention and support, and we hope you enjoyed learning as much as we did.